So remember that an electromagnetic wave is a wave where you've got an electric field and a magnetic field creating each other, traveling along. You'll note that both the electric and the magnetic field are traveling sideways to the direction that the wave's traveling, so electromagnetic waves are transverse waves, and you note that the electric field and the magnetic field are also at right angles to each other. The direction of the electric field, whether it's going up, down, or side, is known as the polarization of the wave. So how do these things start or stop? Well, the best way to make an oscillating electromagnetic field is to take some charges and oscillate them. So if I was to have, say, a vertical antenna, and I was to move the electrons up and down by driving them with a voltage, then that would cause the electric field to go up and down in that direction, and so I'd tend to start an electromagnetic wave to radiate off from that with the same frequency that I was oscillating the electrons, and the polarization of being in the direction of that antenna. And what happens when an electromagnetic wave hits a charge? Well, it's got an electric field and a magnetic field, so it's going to apply forces to that charge, so it's going to accelerate it. So if I want to particularly receive the signal from an electromagnetic wave, the best thing to use would be an antenna, such that the electrons or the charges in it are free to move in the direction the electromagnetic wave is oscillating. It turns out to help for efficiency purposes if the antenna has a size that's roughly commensurate with the wavelength that you're trying to emit or receive. And so you need the same kind of antenna to emit or receive, and it needs to be on the order of sort of a millimeter to a meter for microwaves and high frequency Wi-Fi, and often bigger than that for TV and radio.